Welcome back to our conversation on the forefront of photonics innovation. Today, we are talking to a legend and also to a loyal supporter of Optica's work, Jason Eichenholz. He's now the CEO of Relativity Networks, based in Orlando, Florida. They recently hit the headlines by raising funding to address the growing power requirements of AI data centers. The secret lies in the company's hollow core fiber innovation. Jason, how and why are you changing the world?
So it's interesting. After my last company, Luminar, I retired. I was really focusing on philanthropy, but I was approached by Professor Rodrigo Amezcua at Creole about some technology. We started looking at the markets. It was hollow core fiber. It's a photonic space. And I realized this was one exceptional opportunity that I just couldn't sit out. So instead of coaching and mentoring him and go try to find a way to go do it, we saw the insatiable demand from a market perspective. It's in the photonic space. It allowed me to do what I love, which is move photons from point A to point B. And here I am back at it again.
What makes hollow core fiber the technology AI infrastructure has been waiting for?
So hollow core fiber isn't a new thing. In fact, it's really interesting. I wrote an article in Laser Focus World more than 20 years ago talking about photonic crystal fibers and air core fibers. But this time, there's a killer app. The killer app is latency. That is the difference with hollow core fiber and being able to bring it to scale to meet the needs of the hyperscaler environments, the people who are trying to get data from point A to point B and are now constrained with a major, major power problem.
Can you walk us through why hollow core fiber, when it comes to latency, is fundamentally better than traditional glass fiber?
So fundamentally, fiber optics hasn't really changed since the 1960s. I mean, there's a Nobel Prize for Cowan in getting the losses down in glass fiber. And that works on taking two different indices of refraction, total internal reflection inside a glass fiber core. In this case, in a hollow core fiber, they're guided through essentially an anti-resonant tube. The light is confined in air, and because of the index of refraction of approximately 1.5 versus 1 of air, light propagates at the speed of light divided by the index of refraction. So light propagates 50% faster. And what that does is that then opens up 50% further range for data centers to be located further apart and still hit the latency specifications that they need.
And here come relativity networks. You make a claim that you can be nearly 50% faster in data transmission and extend the range by 1.5 times.
Correct.
What's the secret sauce here?
The secret sauce is literally the speed of light changes when we go through air, and it's 47% difference if you go through and you look at the Sellmeyer curves and you look at the types of glasses that are used versus that of air. It light goes through faster. In fact, we had a customer once. It was really interesting. One of our first alpha customers put light down through an OTDR, and at first they're like, "Wait a minute, you didn't give me enough fiber." And it took them and us a second to realize, oh, no, no, no. That's just the fact that the OTDR isn't calibrated for an index refraction of approximately 1.
Hollow core fiber has been in the academic circles for years. I have been to Poland, Professor Businski drawing tower. Then I went to Glow Photonics in Limoges, France. I saw the drawing tower there. A couple of weeks ago, I went to Southampton. What allowed Relativity Networks to commercialize it and why now?
So now is the exact right time. So as I mentioned 20 years ago, writing that article, and the application for hollow core fiber was to deliver femtosecond pulses from a laser to a multiphoton microscope a couple meters apart. And if you lost half the power after going a couple meters, the loss was defined in dB per meter,
Yeah.
not in dB per kilometer or sub dB per kilometer. Everything changes. In our case, the technology started with at the University of Central Florida at the College of Optics and Photonics, designing these anti-resonant fibers for directed energy and high power laser beam delivery. It turns out if you can put kilowatts and kilowatts, multi kilowatts of power down a hollow core fiber and it doesn't burn up, your losses are going to be low. If your losses are low, you can change the design of the fiber, slight changes to the design, and then you can have it work in the telecom wavelength bands, and you can deliver low cost fiber to the market. You can deliver high that in low cost in terms of orders of magnitudes of what it used to cost for just a few meters. Now it's what you would pay for the kilometer of it. And this opened up that whole new market.
In your article in the Fortune magazine last year, you said a beautiful sentence, which is, we could either make the cable ourselves or we could teach a partner how to do it. Last week, you announced a partnership with the Italian multinational cable company Prysmian. And this marks a key shift from prototype to industrial scale production. Why did you select the production plant in the Netherlands? And what does this mean for the fiber optics supply chain?
So if you may recall, well, I think when we first met years and years ago, I had a company, Open Photonics, was an
Yes.
open innovation company. The idea was working together, finding technology outside the four walls of your company to accelerate the adoption of photonics technology. That was my goal, almost 20 years ago, probably 15 years ago or so. Now we have great technology coming out of the University of Central Florida. We've got an incredible IP position. We have this market pull asking for the technology with an insatiable demand for our fibers and cables. And cables are a big part of that. It's not just the fiber. And so what we wanted to do is ensure that we had adequate supply chain for not only the people we identify today, but for also everyone further down the road that we know would be needing these fibers beyond just data center applications. And so because of that, as I said, we did an analysis. We looked at what it would take to build a building and establish a facility to go make hollow core fiber. Or what would it take to take people, essentially, is what I've done throughout my career, hire people smarter than me. So we've got an incredible team in Eindhoven, in France, in North Carolina, as part of the Prysmian team, executives who had the vision to see the market as it was nascent and beginning. And now we can take the world's experts and people who make millions and millions of kilometers of fiber per year, sometimes per draw tower, and teach them how to make our fiber and how to put that into their supply chain, put that into their manufacturing process, and scale up as quickly as we can to meet that need. Comes from being an open innovation mindset versus a closed innovation mindset.
Time flies. It's already been 3 years since Microsoft acquired Luminosity. How does Relativity differentiate from competitors already moving in this space?
Well, that was a great data point, and I'm really impressed both with what Luminosity has done in helping move this technology to market, coming a spin out of the University of Southampton. My co-founder Rodrigo got his PhD at Southampton. We know the team there, and I really got to give credit to Microsoft for 3 years ago seeing this need before others were able to see the need and act upon it. What that did is that created a data point. That data point was there is a need for this fiber, there's a market demand, and there's a value for fiber for the hollow core fiber for data centers and Gen AI. Kudos to them. They saw that coming and they were ahead of the curve. Long before Chat GPT became commonplace, they knew that. Our goal is to sell hollow core fiber and cables to everybody who wants it openly rather than being closed in distribution to just one customer that acquired them.
You raised 4.6 million in pre-seed funding. Congratulations. To talk to investors about this, mostly you had to tell them about early adopters. Which markets are driving the fastest adoption?
So, as I said before, we've got an insatiable demand for fiber. We've got customers who want pretty much every kilometer of fiber we can make, and we're struggling, like everybody is, to how do you quickly ramp up production? We're not struggling as much now because we've got Prysmian on board. And I spent my entire career trying to focus, really professional career for the last 30 years, focused on bringing technology to market. This is the first time in my career where I am not pushing technology into the market. I'm not pushing carrier envelope phase stabilization. I'm not putting the new power meter onto the market or a new spectrometer or something for an application that doesn't exist, not able to prove the market. This time, the market is super, super easy to quantify and show. But it gets even better. Once we get investors to see the power problem is the number one thing driving this. Those investors can't unsee it. And sometimes a week later, they come back and they say, okay, I've seen 3 articles in the Wall Street Journal, 2 in the New York Times in the last 2 weeks. I get it. I understand. What do you need? Today, investors are pouring more than $500 million of investments into photonics space for AI and data center problems. You just had a similar podcast a couple weeks ago talking about that with Celestial. This is a huge market. I've been through this before. I remember this in the late 90s and early 2000s with the telecom boom. I've seen this before. This one's very, very different.
Let's play the crystal ball game. Let's understand in 2030, what is your preferred future for Relativity Networks? What will the company look like then?
So that's a great question. And, so part of what's helping raise capital easily is the experience of taking a company and going from 2 employees to 1,000 employees, building, showing that dream of where you're going, closing deals, raising $1 billion of capital, taking that public on NASDAQ. That vision needs to be explained to other people to see that. So our company name is Relativity Networks, not Relativity Fiber. And that's because there is right now, we are on the precipice of a huge fundamental change in fiber optic communications. Because for the first time, you have the ability to have high volumes of optical fiber. You can change the zero dispersion wavelength. You can change the loss curves. You can tailor that to whatever wavelengths you want. Nonlinearities are orders of magnitude lower. When all of that happens, you have a fundamental physics shift, and you're changing the speed of light on top of that inside of fiber. Everything should be re-optimized for this next generation of fiber. And that's why we're called Relativity Networks. The next thing we're going to be looking at are the transceivers and the amplifiers and how you do switching. Everything is going to change over the next 10 to 20 years, which is why this was so hot technology at the conferences. There's a session on Sunday coming up at OFC talking about hollow core fibers. This is a fundamental change in how we look at the global connectivity backbone and enabling an AI economy. We are directly enabling an economy. In the telecom boom, it was nice to have. In this case, if we don't address the power problem, if we don't figure out a way to solve for the fact that Gartner is saying 40% of data centers will be underpowered by 2027, just 2 years away. The data usage, more than twice the usage for data center, we have a major power problem. If you and I were having a conversation 6 months ago talking about how Amazon was going to go buy a nuclear power plant in Pennsylvania, how Microsoft was going to turn on 3 Mile Island, you would have laughed me out of the room. You've got both. So you've got the solution for the power problem over the next decade as alternative energy sources are coming up, and you get to fundamentally shift the AI economy with fiber optic communications in a whole new way.
Jason, congratulations on what you are putting together. Thank you very much for bringing it to Optica, and I look forward to seeing you next week at OFC.
Perfect. Thank you.
Thank you so much.